So here in the other video, I was showing you how to graph a logarithm by hand, but here I'm given the graphs and I'm trying to figure out the equations. And what I want to remind you of is our parent function, y equals a log base b x minus h plus k. And when we look at this, the a value, like in all of our functions, the a value stretches it vertically and flips it over. The b value determines the growth rate. The h value shifts the whole thing left and right. And the k value shifts the whole thing up and down. Remember also that our parent graph looks like this. Has a vertical asymptote at x equals 0. And it crosses through the point 1, 0. So one step away from the asymptote, it's reaching a height of 0. So what's going on here? I'll start with the red graph because it looks more like our parent graph. The first thing I notice with the red graph is that it has this asymptote here at x is equal to 5. Okay, and I'm going to kind of drag a little further over because I want to be able to see a little bit more of the graph. There we go. So I'll have to erase that. So the first thing I notice, like I said, is we have a vertical asymptote at x is equal to 5. And I already know that I'm going to have y equals something log something x minus 5. We're getting there. The next thing I notice, I need a couple points. The next thing I notice is that we have that 6, 0. So it touches the x-axis one step away from the asymptote, just like I mentioned. Then we get to a height of 1 when x is 8, 1. Where's my next whole value? Y equals 14. Sorry, x equals 14, y equals 2. So I'll go ahead and write those points on there. So what did we just say? 8, 1. Here was 6, 0. Here was 14, 2. And remember that what we're always related back to is the asymptote. So when I see 6, 0, I actually think of that as being one step away from the asymptote. When I see 8, I actually think of 8 as being 3 steps away. So 6, 0 is 1 step. 8 is 3 steps because we're relating it to 5. And then 14 is 9 steps. So what are we seeing here? It's multiplying by 3. That's our base right there. Log base 3 of x minus 5. And in fact, that's all we need to do here. Now, how do I know that's all we need to do? Because it wasn't flipped over. It's pointed in the right direction. It's going up and to the right. And if I actually plug in my numbers, 6 minus 5 gets me 1 step. The log of 1 is 0. That works. Let's try another point. 8 minus 5 is 3. Log base 3 of 3 is 1. Let's try one last point. 15 minus 5 is 9. Log base 3 of 9 is 2. I don't need anything else because it's already working for the 3 points that I have right there. And you can't have 2 different logarithms that agree with at least 3 points on them. Now let's move on to the green one. When we look at the green one, I notice instead of it being at x equals 5, we've got an asymptote at x equals -2. So I know that we have y equals something log something x plus 2. Now let's look at the values of as this grows here. What I'm seeing is that I'm going to go back to my mouse so we can look at this. It looks like we've got -1, 0. So that's 1 step away. Then I want to get to another whole value all the way over here, 3, -2. And then if I want to get down to another whole value, I'm going to need to get rid of my video here. Where are we? Right here, -3. And if I wanted to get all the way down to -4, I have to go quite a ways. All the way to 23. Is that right? Come on, work with me. Yeah. So we'll utilize those different values there. The reason I wanted to get another one is just because the numbers didn't look so pretty on a couple of those. So I just want to make sure that I'm getting some nice values here. Let me clean up a little bit because when I zoomed out, things got goofy on me. So let me clean up a little bit. We'll get rid of the red stuff, except for the answer. And we'll start relabeling the green graph. So bear with me for a second. All right, so like I said here, let's label those points. What did we just have? Here is -1, 0. Here where do we get the next nice whole number? Right there. 3, -2. I'm just looking for whole numbers because they're things that we can work with. 3, -2. And I'll explain why it's a little harder on this one to find the whole numbers. And if you notice, we get down to y equals -3, but it's not a pretty number. It's like 9.3. So we got to go all the way down to y equals -4. What did we get? Was it 23, I believe? 23, -4. Okay, we can work with that. All right, that's the hard part. 23, -4. Now let's relate those to the asymptote. The first point was 1 step away from the asymptote. The second point was how many steps? 5 steps. 5 steps away from the asymptote. Don't jump around on me like that. There we go. 5 steps away from the asymptote because our asymptote was -2. So 5 steps. And then 23 is 25 steps away from the asymptote. So what's going on? 1, 5, 25. We just determined the base is 5. Now the last piece of it is why are my y values going down by 2's? Notice when I tried to go at y equals -1, I had a nasty decimal for the x value. When I was at y equals -3, I had a nasty decimal. And the reason is it's going down because it has a -a value. And it's going down by 2 steps every time because it was stretched out by a factor of 2. To be honest with you, it is a challenge to figure out the equation of a log graph based solely on the graph, the equation of a graph there. So a lot of times what you would see instead is like a multiple choice. And then you're looking at, okay, where's the asymptote? You're looking at, is it vertically flipped? And then maybe a couple other things on there. But anyway, that's the video right there. Please feel free to ask if you need any more like that.